Uh, Good afternoon. This is our assignment for CS522 database management system. These are the group members. The topic that we choose is hospital management system. So a hospital management system is a software application designed to streamline and automate various administrative and clinical tasks within a healthcare facility. It centralizes patient information, medical record, appointment, billing, and other critical functions, improving efficiency, accuracy, and patient care. So our requirement for this simple hospital management system is that we are going to create three tables or entities which will contain some vital information. The information include patient, doctors, and appointment. The entities and relationship are the patient. These are the patient this consists of the patient data, including personal and contact details, and also for the doctors, the the hospital doctors, their specialties and contact details, and also for the appointment, the relationship between patient and doctors regarding when they meet and for what reason. So our database schema will be in the three main tables, which are patients, doctors, and appointment. So each table here will have a primary key. Foreign keys will be used to establish relationship between patients, doctors, and appointment. The data types and constraints are appropriate for the field. So our patient's data here, this one will store the patient information, the information about patient. Here, these are the schema for creating the table here. We have the patient ID, which will be an integer type, and it's going to be the primary key and auto incrementing. It will be auto incrementing when a new patient is added. It's going to be it will start from number 1, 2, 3 up to the last record. So this one first name is going to be of variable character of length 50 and going to be not null. That means a not null data is not going to be given. Like the table must contain a first name and also a last name. You cannot leave it blank or empty. And here we have the gender is going to be male, female, or other. Anything apart from these three is going to throw an error. It's also going to be a not null. Here we have a date of birth of type dates, and it's going to be not null also. And here we have a phone number, also a variable character 15 is going to be not null, and it's going to be unique. That means when a phone number is added, it cannot be added further. And here we have address. Let's go of text fields. This text fields, the text fields here is if length is greater than this variable character and created that means the time that data is created. It's going to be adding a default current timestamp. It's going to be like adding the dates, the time, and the seconds, and so on. So here in this table, we have a primary key of patient ID, and the data types are a variable character for text, date for birth date or date of birth, and enum for gender, and a text for address. And the constraints here are not null for mandatory fields, unique for phone numbers. So here, the doctor's table will consist information about the doctors. Here, this is the schema for creating the table of the doctors. Here, the doctor ID is going to be integer, primary key, and also increment also. Here we have first name, last name, specialty. They are all going to be of variable characters of certain length, which the first name is going to be 50, the last name is going to be 50, and the patient is going to be 100. And also for phone number, variable character, and also we have email. Also, it's going to be not null. And also we have the created here at the timestamp. going to be also going to be adding the default like current time that the data record is added. Here we have a primary key of doctor ID and also data types variable character for text and content information here. As you can see, this the phone number is variable character, the email is variable character, and also constraint are not null for mandatory fields unique for phone number, for phone and email. That means like an email or phone number, like when they are added, a duplicate value is not going to be added again. So here, the appointment table here, this will store the information about appointment between patient and doctors. Here, this is the schema for the creating the table of appointment or appointment table. Here we have the appointment ID of integer type and primary key, and also it's going to be auto-incrementing. And we have the patient ID, it's going to be not null of integer type, doctor ID not null of integer type, and also appointment dates of not null of date type, and the reason for the appointment of the text type, and also the status going to be scheduled, completed, or cancelled, and it's also going to be not null, and the default is going to be scheduled. That means when this thing is not inserted, like this field is not like kind of created when inserting, it's going to be just make a default of scheduled. Any other text apart from this scheduled, completed, and cancelled is going to throw an error. And also the created ad is going to put the current timestamp or the current time that that record is inserted. And also we have a foreign key of patient ID, which will reference the patient there and its patient ID. So also we have the doctor ID here. Is going to be referencing the doctor ID in the doctor's table. That means this patient ID and this patient ID, like they are going to be a foreign keys for patients and doctors respectively. So these are the constraints for the appointment table. We have the foreign key. Patient ID is going to be referenced to the patient ID in the patient table, and another foreign key for the doctor is going to be referenced to the doctor ID in the doctor's table. So here we have primary key. The appointment ID is the primary key of this table, and the foreign keys we have patient ID references, which will reference the patient table, doctor ID references doctor's table, data types. We have dates for appointment date, text for the reason, and enum type for the status. The constraint ensure valid references to the patient and doctor's tables. So here is a sample inserting a sample data into the patient table. Here we'll insert, this is the query for inserting the sample data into the patient table, which we have insert into patient. This will take first name, last name, gender, date of birth, phone number, and address. These are the fields there. And we have the values that are going to be inserted, kind of 1, 2, 3, 4, 5, like kind of 5 records. We have the first name here, Aliu Hassan, gender type of male, date of birth 1985. Here the phone number. We have the address here. This address. So this is something. So this one is inserting a sample data into the doctor's table. We have this. This is the query for doing that. We have insert into doctor's first name, last name, specialty, phone number, email. We have the values as follows. Also 1, 2, 3, 4, 5. We have the first name here, Jamila, last name Sani, specialty cardiology, phone number. This one, email Jamila Rosani, so and so forth. So this is inserting a sample data into appointment table. We have this one insert into appointment patient ID, the foreign key of the patient table there. Doctor, this one is the foreign key that will reference doctor ID in the doctor's table, appointment date, reason, and status. We have this. These are the sample values. This one, 1, the patient ID, doctor ID for this specific record. We have the date for the appointment and the reason and the status, whether scheduled or completed. And even if we leave these fields as blank, and we know who this one for default is going to insert that schedule. So this one. So this one here, we have the created indexes. For performance optimization, we create indexes on columns that are frequently used in the queries for lookups such as appointment date and doctor ID. This will help speed up the retrieval of appointment-related information. We have two indexes. The index on appointment date optimize query performance on date searches. We have a create index. This is the query create index IDX appointment dates on appointments. It's going to represent the appointment date in the appointment table. This one also index on doctor ID to optimize performance when searching by a doctor. We have create index IDX doctor ID on appointment, going to take the doctor ID inside the appointment table. So this is some of the important queries for retrieving records. This one will retrieve all upcoming appointment. This query retrieve all appointment schedules in the future. We have it will select a dot appointment ID, P first name as patient name as patient first name, P last name as patient last name, D first name as doctor first name, D the last name, and so on. So this one, this A is going to be inside this appointment table here, and this P is going to be inside this patient. It means patient table here, and this D means doctor's table here. We are joining it, raising a join statement here. So this one also is for finding all appointment for a specific doctor. Here we have this query with all appointments associated with a specific doctor identified by the doctor ID or name. For example, we are taking appointment for Dr. Chen Smith. We can search something like select A. It's going to be A dot appointment, P dot P's name. So this one is going to join the table of appointment. It's going to select it from table appointment and join it with the patient ID, where patient ID in the appointment, where patient ID is in the appointment is equal to the patient ID in the patient table. And also it will join doctors on D, where doctor's ID in the appointment table is equal to the doctor ID in the doctor's table. And also like where the first name that we pass here Chen and the last name that we pass here is Smith. So this one is another query for counting of appointment by status. You know, in our table of status, in our table of appointment, we have a status. So here it will select status, it will count all the status that we have as appointment count from appointment here. Then it is going to be grouped by status. So here we are concluding the tables created. We designed 3 tables: patient, doctor's appointment, appropriate data types and constraints, inserted record of 5 indexes and so on. Now let's try to see how this one works in practice. So here, let's start by creating our database here in MySQL in PHP So here, let's create the database here. Let's create hospital management, hospital MGT here. Correct. So here, let's enter this SQL. Then we can come and copy our query, our schema for creating the patient table here. We can just write this one here. If we like, so you can just click on this run. Then it will, as you can see here, we have this is our database management system, and this is our patient table that has been created. You see patient ID, first name, and so on. Now, because of time factor, let's come to and create our doctor's table here. Here. So here we have created our doctor's table. Let's enter another spell. Yeah, let's try to create. Let me copy the remaining details here. The appointment. So here we created the appointment table. So let's go around our table for the insert. Let us see. The next thing here is inserting a sample data. So let's write insert a sample data. Yeah. For the let us start with the patient here. Let's come on the page here. You see we created this one here. Okay, because this is the area here. The paste, we have fixed that. So let's try to insert records into the doctor's table here. As let us enter the patient that we inserted earlier. You see the record here earlier, and so on and so forth. Let us come to another student. Let's try this one also. Let us now give this space here. So let us enter and see the record of the doctor's table. So now let us insert for the appointment table here. So you can see this one. Let us also add the space here. So here, now we added the appointment also. You can see the record of the appointment. You see this one is referencing the patient here. As you can see, this one is also referencing the doctor's table here. So let us what is the next step? We are on with inserting the sample of the data. Now let's work on the indexing. Yeah, let's see. This is our indexing. Let's create the index here. This one. Let's see. Here. Here we see we created the indexing. So also this one here, let's create the indexing. Optimize the performance. Yeah, also we are done. So let's see. Now the next step is going to be retrieving all upcoming appointments. Let's copy this one here. Come and insert it here. Let's see. As you can see here, this is the output that we are getting. This is the appointment. We have the patient name to be Musa, patient last name to be Bala, and the doctor is Saude, and her last name is this, and the appointment date is this date, and this is the reason for this one, and this is the reason for the second one, for the second appointment. So this one, what we said that here, we are getting the appointment like that, like the appointment date, is it greater than the current date? That means if the appointment date not today, like not today, not yesterday, not a day before yesterday, like it starts from tomorrow, next tomorrow, and so on and so forth. So as you can see, these dates, as you can see here. So now let's start to find all appointment for a specific doctor now. Yeah, specific doctor. Let's go to this first. So as you can see, we don't have Chen Smith in our doctor's table. That is why we are getting this info. So now let us copy this one and go and check the doctors. Let's check for Jamila Sani and see. So now let's send this name to Jamila, and the last name to be Sani. So that we can see. So see, we have now for Jamila Sani, the patient that she's going to see is Aliyu Hassan. The reason is heart checkup. So now let's see the other one. This one, the other way is count of appointment by status. Let's come here and run our query here and see. You see now the number of appointment that we have is we have appointment that are scheduled. We have 3. and appointments that are completed, we have 2. So this is the end of this of the presentation. Thank you, sir.